Alright, so for my demonstration I want to talk about buoyancy and Archimedes' principle. And so I have this orange here that has not been peeled. Still has the peel on it. We're going to weigh it. It weighs 4 ounces. So let's put it in the water and see what it does. Will it float or will it sink? And as you can see, it floats. It's very buoyant. I can push it down, pops right back up. And so the orange with the peel clearly floats. I also have an orange here that has been peeled. Let's take its weight. It weighs 3.8 ounces, so it's a little lighter than the one with the peel on it. So the mass is less than the unpeeled orange. Put it in the water, and it sinks. So for this, I want to talk about Archimedes' principle and why the orange that is peeled sinks while the orange with the peel on it floats. So Archimedes' principle states that when an object or a body is completely or partially immersed in water or in a fluid, it experiences an upward force that is equal to the weight of the water that is dispersed by that object when it's immersed in the water. So that's kind of confusing the way I said that, but I'll kind of explain to you and show to you what that means. So what I want to do next is I'm going to take one of these bowls. I'm going to zero it out on the scale. And then I'm going to fill this cup of water to the brim with this cup to the brim with water, and then we'll weigh the water that spills out when we place an orange in that. So I'm carefully filling it up. And perfect. Okay, so that is right to the brim. And so when I place this unpeeled orange in the cup, it'll push water out. And we want to push the same volume of water as the orange. And so that's what I've done there. Now I'm going to carefully take my cup and orange out. And we will weigh this water. So we get a weight of 4.5 ounces for the water. And if you remember, this orange weighs just 4 ounces. 4.1 ounce, 4 ounce. And so, as you can see, the mass of the water is greater than the mass of the orange. And so there's a greater upward force on the orange than there is a gravitational pull by the orange. And so the orange floats in the water. Now we're going to do the exact same thing, but this time with the peeled orange. So first I'm going to zero my scale out. Grab the paper towel, wipe the cup, get all that. Okay, so we put the water, I'm going to fill it to the brim. Getting kind of close. Ooh. Perfect. Okay, so now I'll place this in it. Whoa! Because the orange sinks, I don't have to push anything down, but alright, so now I'm going to carefully remove this cup without spilling any water. And we can weigh. Okay, so we get a weight of 3.4 ounces is what the water weighs. Well, making a bit of a mess. Zero the scale out, and the orange weighs 3.7. So the water was 3.4 ounces, and the orange was 3.7 ounces. So there's a greater gravitational pull than there is upward force from the water, and so the orange sinks. So that's basically what Archimedes' principle is, that the water displaced by this orange has less of a force than the downward force of that orange. And so this orange sinks. Yeah. Now, let's say that this is the ocean and it's salt water. So we're going to put some salt in here. Don't know how much it's going to take. Stir it around. And let's try this again. So this orange still floats. And let's see what this orange does. As you can see now, both oranges are floating in the water. That's because the density of the water has changed, and so the water displaced by that orange now has a greater weight, and so there's a greater upward force on the orange. Maybe we need a little more salt, but that's the principle. As you can see, it was more floaty when there was salt in it. All right.